Hi everyone, I'd like to welcome you to our 28th Masterclass, which is going to be covering non-photorealistic rendering. Now, the techniques that we go through today are going to be principally built around things like shaders and also custom lighting solutions. And what we're going to try and do is we're going to try and build some more comic-oriented rendering while still maintaining a fair high degree of quality. One of the things that you will see typically when you do non-photorealistic comic style rendering is things like inverted shells on meshes that produce that cell shaded outline. What we're going to do today is actually dive into some more interesting techniques like using what's called signed distance fields to create more intricate and detailed line rendering. We used this technique on a project for a client many years ago, a project called City Run. We used some very similar techniques for rendering something that was designed to look like the French artist Mobius. Today I'm going to go for a slightly different aesthetic. We're going to go for a Japanese artist who goes by the name Imperial Boy. And I'm just going to flip through some images very quickly before we get started today, just showing off exactly the kinds of effects and things we're going to be looking to build. And that's quite important because we want to look at the colors that are in use, how those colors are actually mixed. So if there's gradients, if there's just lots of flat shells with lots of detail, and then we'll actually build from here into how these things work. So I'm just going to flip through a couple of these images. Now I know that they won't come through terribly clearly on YouTube, but if you just search for Imperial Boy on Google, you will find a whole bunch of his related art. So I'm just going to tag through a couple of these things, and then I'm going to go back a little bit just as we prepare for this project and work out exactly what sort of effects are in place and what we're going to need to replicate. So I might take this image here just as a starting point. And one of the things you'll notice is, obviously it's very detailed and intricate, but the colors actually in use are pretty flat. When you actually dig down into these things, ignoring things like lighting, where there's a volumetric fog applied, and we'll come back to that because that works really well with these techniques. If you actually look at the underlying surfaces, aside from those bits of lighting, the colors, for instance, on these leaves here there's 3 or 4 actual discrete colors in use here. There's not sort of a wide gradient or spectrum of them. And you see that consistently. The buildings, there's 1 or 2 colors depending on the lighting. The ground, the surfaces, all those bits and pieces, it's fairly flat. Now where the complexity and detail comes from is things like the reflections. It comes in from the small little dots of specks of dust and things that have been left around these environments that really sort of produce the overall look that we're looking for, that will actually create something that's quite nice. The areas where you do see gradients though, for instance on this image is in the sky, you've obviously got a white to blue gradient there, but the use is very subtle and we don't use a lot of it. We're going to follow this up with a few other things. If you look at the actual inside the shading, what we have is we usually have a flat color and then we've got a secondary color beneath it. Like for instance along here we've got the line art, and that's what we're going to use today is, as we flip through a few of these things, is how to use signed distance fields to create line art that actually looks a bit more robust than you typically expect elsewhere. Today's output probably won't be the world's highest quality, but what we can do is we can build on these techniques and just sort of go over and over again to create the overall final look that we're looking for. So the very first thing we're going to have to do is actually put together a shader. This shader will be the very starting point for how we build the art. So what I'm going to do is I'm going to start off, I'm just going to create a new new folder just for this project. This is going to be our non-photorealistic demo. And then we should be able to come into some stuff like shader replacement on avatars, so we can actually get the avatars looking like they fit into these environments rather than sticking out like a sore thumb. So I'm just going to save this new scene I created. I just created a new science-based scene, just so we've got something to work with. And this should be here. So we'll call this NPR Lesson 1. The next thing I'm going to need to do is to dig into the actual shader. So I'll create a box in the scene. This is going to be our very, very rough starting point here. Okay, there's our box. I'm going to create a new shader. I'm just going to do this as a surface shader. So just a standard surface shader here. I'm going to call this NPR Outline Shader. Now, one of the things to note when we actually look at one of these images and how we want to translate these into a 3D environment is actually have choices on how we want to define things like the gradient. Like for instance, if we go back to the one that's got the more clear gradient, do we actually want to have that gradient fixed, or do we want to make it actually move around in relation to the the avatar. What we've, with relation to the camera, and this is sort of screen space rendering. I think we've touched on that once or twice before in our projects, but to begin with, I'm just going to pull open our shader. Just give this a second to fire up. The other thing we're going to have to get up is just our CG functions list, because we're going to be making a big use of this one. NVIDIA have a great list of documentation on these things, and there is a something width one that I'm just going to quickly scan for that's going to be quite essential to how this technique works. There is one for width. It's F width, that might be it. I believe it is, that's the fragment width, I think. Yes, okay. So one of the things we've got is with line art. If I just make in Photoshop a very, very quick line art sketch, we're going to see the limits of just actually just painting them onto the textures. So let's create a new 1, 2, 3, 4. I won't even need to make them at this resolution for this shader technique. We can get away with quite low resolutions. Okay. So what I'm going to do is I'm just going to paint some bricks. This is going to be sort of that hand-painted look that we want to go for. Just top that around. Photoshop being a bit slow. There we go. So this is programmer art at its finest, but we will actually clean it up and make it a bit more interesting when we get a second. So could almost be wood panels, but all right, we're just going to save this one off to our directory here. Okay, what do we call this one? It's going to be just a simple. Now we're going to do some modifications to this texture as well in a second. It'll make more sense once I actually get this on and build a material. It's just got that on it. So. Okay, so one of the things we've got here is we've got something that looks kind of hand-painted, but one of the big problems is that as we get closer to the object, these lines get wider, and as we move further apart, eventually they will just disappear. As you can see here, they've sort of just faded out to black. Now, that's partly the mip mapping, and we can control that a little bit inside Unity when we play with the mip map settings, and they are somewhere around here. The mip map filtering, we can change them around a bit to try and get a bit of a rougher cut so they stay sort of angled at that point. But the alternative is what we can use something called signed distance fields. Now if I just Google a signed distance field, you should get a quick understanding of what they are. So a signed distance field is like this. So that image is the signed distance field, and that's the original. Now when you look at the signed distance field, what the actual gradient represents is not the outline of the image itself, but what it actually represents is the distance to it. So the distance from the nearest illuminated point is going to be represented on that gradient there. Now what the neat thing here is we can do is we can mathematically change, if we just define this as a simple Boolean on-off state, so it's either white or black, what we can do is we can actually change what level of grey is black. And by doing that and alternating that based on the distance of the object from the monitor, or from the camera in the scene, we can in fact create line art that preserves its integrity as you zoom in and out. So what we're going to do is we're going to say, if we look at this box here, and right now that line is 1 pixel on that line might be 1 centimeter. It isn't, but for the sake of it, it is. So at this distance, it's 1 centimeter is 1 pixel. At this distance, it's more like 4 or 5 centimeters per pixel. And if we go down to this distance, it might be 0.1. And what we're going to do is actually use a shader function, which actually lets us define the width of the surface being rendered. And we can divide the width of the pixel on the screen, or width of the area, the surface area to the pixel on the screen ratio, by that signed distance field gray level. And I admit that gets a bit mathy, but the net result of that means that we can define something that gets thinner the further it is away from the camera. So what we'll do, and I will need to poke around this technique because I remember when we last did it, it did take an afternoon to get that right, but I'm hoping that second time around that we can get this going a bit faster than usual. Okay, so I've just got my shader here. Now, what we're going to do is, first things first, we're just going to bring in the screen coordinates, and I'll do that just for another reason, but I think it's screen pause. I'm just going to go to Unity shader manual. Never be afraid to use this thing, it's useful. Okay, so let's pull up our, as usual, the surface shaders examples page on the Unity wiki is really useful because it just has all the bits and pieces we actually want to see. So we're just going to grab the screen coordinates. It's just useful to have. So it's a float force, the screen pause. Lowercase f, I should have known that one. Okay. So the first thing to do first actually is we just need to convert this to an Sdf texture. Now there's a Unity asset on the asset store called Sdf Toolkit. It's free. There is a paid version as well, but I'm just going to use the free version for today. And as you can see here, we've got our Sdf generator. Okay. Hopefully this won't take too long. The bigger the Sdf texture, that 1024 texture is too big for this stuff. Typically you want to do this on 512s. Just because it doesn't take very long, and also because of the way this technique works, lower resolution images don't lose too much detail. It's really only on a big image do we actually care about that. And I'm not sure we've got that here, so I'm just going to run that through once more time. If it doesn't work here, there is actually a trick to doing this in Photoshop. I just prefer not to do it that way because it's not as accurate. Okay, if we're going to do it in Photoshop, I might as well just go straight to that. Okay, so I'm just going to take the layer outline here, and I'm just going to literally add a drop shadow to it. As you can see here, drop shadow, actually a bit outer glow, sorry. Outer glow, and you just set the mode from technique from softer to precise, and that will do exactly what we want. So I'm just going to set that to black. And as you can see here, we can expand that. A little bit unsure why that's not being as soft as it should be because the spread was so high. Okay, so here we go. This is going to give us our SDF and also our color as well. Didn't realize that, but we'll fix that quickly. There we go. So now what we've done is we've just very quickly created an SDF texture that you can then keep on modifying. And obviously, as you can see, the distance represented here is really the distance to the object. So I'm just going to save this, in fact. Take it back into Unity. Give us 1 second. Okay, now, as you can see, that's not quite the original we had before. So the first thing we're going to need to do is just change our shader so that the material matches. And to do that, I'm just going to set this to use our new shader. So let's show up in the custom, and we're on MPR outline shader. Okay, fantastic. So now we can just start editing away. So the first thing we'll do is we're going to define some new colors. We're going to actually we're going to take 4 colors in this shader. We're going to take a base color, we're going to have the line color, and we're going to have the actual surface color. And what we're going to do is we're going to define this as 2 colors for each. We're going to have a gradient, so we can create soft effects on this. So what I'm going to do is just call these G1, line 1 and background 1 will be our colors. So I'll just go background 1. And line 1 and line 2. Okay, now I'm just going to knock out some of the other things we're now not using. Let's call this line map. Now the names don't matter, but I just have to put the R there just to indicate which channel we're actually going to use here. Now the rest, the glossiness and the metallic, we're not actually going to use, maybe we will use this stuff, so I'll leave that in there. Doesn't do any real harm. Okay, next thing we're going to do is we're going to mix these gradients based on the screen pos. So we can actually get the screen coordinates from from the screen UV by just doing this line here. We'll just cut and paste this one into our shader. Okay, so now we've got the screen UVs, and we're just going to create two colors as a result of this. So I'm just going to go with float. Actually, I'll go fixed, and that just means we're not using too much precision. I'll just create fixed for background is going to be lerp between, or linear interpolate is the term. Lerp background 1 and background 2 based on the screen UV dot y. So just the y coordinate is going to be used there. Just do this as a line. I will release these shaders as well, so the people who are less comfortable actually going in and editing shader files can pick stuff up. Okay, so we just got our two things there. I'm just going to quickly test them, and then I'm going to do that just by multiplying the color by our background color. Okay, so well, it's white now. That's always a good sign, but I think I've screwed up. Yes, I forgot to define my variables. It's always a good thing to do. Just give it a second to compile my changes, and now I've got a new problem. Okay, unexpected time 50. What did I not do? Should be right by syntax error. Unexpected token line. Open. Maybe that's just a reserved keyword. I'll just double check that one. Yes, it was a reserved keyword. Okay. So now it's a little bit blacker than we want. And that probably is something that we've done that's not quite right. What do we do? We multiply that by background. I'm just going to call this okay. So we'll double check this because that should be right. I'm just going to set these to very distinct colors so we can just debug our shader. I'm sure someone in the chat is just screaming at me about what stupid mistake I've made here. Okay, so I've got those guys. Don't want any smooths, no italic. Okay. I'm just going to change that to emission. Something we'll just need to investigate there. It's probably related to the actual pickup. Okay, so now we've just got a gradient that runs from the top of the screen to the bottom of the screen. As you can see right now, it's going a nice even drift through there. If I move it out, it goes red there. Maybe not blue there, but yes. As you can see, based on where the position is, the color's changing and we're getting that gradient. And this is going to give us quite a bit of artistic control over exactly how this is going to look. So, our next thing to do, right, I undefined the color, that's why it's black. That would always help. Okay, so we've got our underlying line texture, we've got our gradient. So what we're going to do is we're going to move between these based on the line texture. So what I'm going to do is I'm just going to begin with, we're going to loop between the background and the line color based on C/R, which is the red channel of the texture. Now the other thing I'm going to do is, just as a useful thing, while having them like this is okay, I find that it's generally better to have these maps inverted, with the white being the important one. So I'm just going to do a quick invert there, just because it's easier to read these things later on, and it also makes more logical sense in the shader. Okay, so we're getting somewhere now. We've got the line color separated. But what we want to do is we want to actually define the actual width of this. Now, the other thing we want to do is get the depth. We'll just try and do that by the fwidth function. If I recall correctly, fwidth is the one we want. Yes, approximate the fragment width. So hopefully that will do the job we need. Okay, so the first thing I'm going to do is just try and work out what the fragment width is, and the other thing we're going to do is we're just going to make this be sort of a Boolean on-off thing. We could use just a simple evaluation here, so I just simply do if that's greater than 0.5, do 1 else 0. That should optimize okay on the shaders, but one of the things to be aware of, and I'm probably wrong here, that's probably fast on the GPU, but has been a problem in the past, is that questions, specifically things like if statements and ternary operators and whatnot, have traditionally actually run both ways on the shader. So what it would do is it simply runs the shader twice, one for each answer to the question, then discards the one you don't want. That is slower, so just as a general rule, I try and avoid those, and I simply write that around by doing something silly like this. So I'm going to saturate. That means it's going to clamp to a value between 0 and 1. C/R minus 0.5, and then take the result and multiply it by 1,000,000. Okay, and that should now create what we're looking for, at least in terms of a flat outline. And I have typoed. Where did I typo? There. Okay, so now you can see we've now got a crisp edge on the sharp, possibly even a little bit too crisp, and we can control that crispness by actually making that number not quite so big. So if I drop that down to 100 instead of 10, we will now get a slight blur on the edge. What we want is ideally something that's a little bit anti-aliased, but not quite. So there's a bit more there, but that's maybe not too much. Let's try 10. As you can see, now we've got a bit of blurring on there. It's a question of how much we want. I think we want somewhere between those two values, so maybe a 50. Some anti-aliasing inside the client will also help here a lot. Okay, so that might be where we go. Not perfect, but we now got those values. Now the width here we want to control. So I'm just going to add a slider here. I'm going to do that as a range. So I'm just going to add a new line width modifier. It's going to be a range from 0 to 1. I'm going to set to 0.5 to begin with. Okay, now I'm just going to change that to here, just so we've got the ability to fine-tune the width of these things. And this is where those assign distance fields come in handy, because now we're going to be able to control the width of the lines on the screen. So, as you can see here, we can make them wider, we can make them thinner. So we can make them almost non-existent. But this is going to have the problem with, as before, where as we move out of the way, the lines are going to go away, and they're going to stay constant size here. So to get around this quandary, we are going to start introducing what's called the f-width. Now I think that we just need to know the scale of this value. range actually. Just do a very quick look up just to see the sample values of this. We might just need to play with this one. So what I'll do is I'll just make it tweakable in the shader editor. And we'll go with the f-width modifier, or f-width scale. And I'm going to leave this one open. Okay, and I'm going to, just because I like using lots of brackets, I think f-width does not take an argument, if I'm correct. We might need to play with this one actually. I'm just trying to think of exactly the right here, because it does actually express this as x and y coordinates, so we're just going to need to possibly test this one. I might just do it on the width and just see how it looks. So let's do ddx 1 times, what do we call it, is the f-width scale. And if I haven't screwed that up, that should do the job. That might be a question that we'll just have to play with. We may also have the number the wrong way around. There's a slight shader there. Sorry, shader error there. So make sure that actually works. Here's someone doing exactly the same thing as us. Very similar technique. Okay, so they're using a rather similar technique to us. So if they've done it before, I'm just going to double check that that in fact works. I might just wrap this all around. So I'm just going to extract a few things and play with them. So, and then we're just going to hopefully that's good to go. Aha, there we go. Not quite the right way around, but theoretically, guessing at least. So that's now is definitely getting wider as we get in, and it's staying roughly the same size. In pixel size, there is some impact here, as you can see. This is still, that is noticeably taller than back here, but there definitely seems to be something going on where it's trying to stay roughly the same size. Okay, so we just need to play around with this a little bit until we got what we want. So I'm just going to change the line width modifier. It's a little bit odd that that's no longer having an effect. Neither is that. we set that to 1000. So that's the scale there, so we can actually test that. And right, we haven't got, just going to take away that line with the modifier there, and then I'm going to do minus, was our line width. Now we should be able to control that. Oh, no, it's still. Let's have a look at what it looks like at 1. Some glittering there, and it's doing something, but it's not quite right there. So I think this is running on an opposite scale as well, or at least it's not quite right. We've also got an unusual gap in the middle there that we just need to work on. I think that might be some sort of overflow or not a number, or something similar to that. But we are definitely getting the effect now where, as you can see, that as we zoom out, the scale of the lines is remaining roughly constant, especially as we get further out. Not quite so much up close, and I think we might need to do some sort of modification there, but we'll just play around with these numbers a little bit. 1. One of the ways that we ended up, I remember, solving on the previous one was also to incorporate the depth slightly. So they've used a modification there to go between alpha and alpha testing, which actually that's quite a clever technique for plants, but it's not quite what we're looking for. Distance-based anti-aliasing might be helpful. Okay, let's just get the depth as well. So I'm just going to do a quick depth lookup in shaders. Right, so to do this, we just need to set up the transfer depth. We'll just add that to our. We have depth and surface shader. Preferably don't want to write another vertex shader if we can get away with it. 3D surface shader depth. Fantastic, that might do the job. Okay, someone's. Okay, so we do need to get vertex shader in. Fine, we will do that. Alright, so we'll just add a float I depth. And just add this sampler in here. And a vertex shader. We're just adding a vertex shader here just so that we can run this one function we need. Okay, so just add that there so it actually uses the vertex shader. What was it defined there? That's unusual. Where is that? Oh, I see. Okay, let's just have a quick look at this and just make sure it still compiles. And this will just let us get a bit more fine control over this because I'm not quite happy with how this works. It's not giving us the exact answer we're looking for. Okay, 2 texture interpolators. When we see that particular thing, it just means we need to do, we'll just raise the target on this one. Okay. Always the right solution. We can actually look at stripping off things like light mapping support, but we won't do that just yet. Okay. So we've got the depth there. I'm just going to multiply the depth, the emission here by this depth value. So we've got a okay, so it's going to be quite bright the further we get away, and I'm guessing the closest we get away, the closer we get, it's going to get darker. Yeah. So that's just giving us an indication that we've got this depth scale available. So what we're going to do is we're going to make some extra parameters here, just so we can control the distances, and this will help impact this stuff. So we're just going to go near and far. Are going to be our two things. This is going to be a float. I'm going to set this to 0.1. We'll set the far distance to 200. Okay, and look at this. Now, what we're doing here is we're creating basically some reference points. So what we're defining is the near distance, and when the near distance is, when the camera is that close or closer, we'll use the near scale as our offset, which will be similar to what we did with the line width modifiers, and then same value for the far away. And this way we can just easily tweak this stuff. This is probably completely wrong, but we'll just play with this. We'll have to play with it in the material to get a good feel for how this is going to look. So we just need to get a reverse lerp. I'll just get a shader lerp. Shader inverse lerp. So we'll just go quick inverse lerp that we can cut and paste. Otherwise I'll just type it up. Fantastic. All right, so we've got the distance. So we've got the value, which is going to be part z minus the near, and we're going to go with far minus near. And we're just going to lerp between this. So what I'm going to do is I'm just going to take away some of this stuff we've done with the modified line values and all that stuff. We may or may not need it. This is stuff with f-width. So what I'm going to do, just simply do that, minus lerp between near scale and far scale based on that distance we've just calculated. Okay. This is going to give us a completely different impact on exactly how this is going to behave. And it probably will be wrong from the beginning. Okay, and yet again, I will learn my lessons here. Although I didn't do too bad a job, actually. It's not perfect, but what I'll do is I'll just leave that off. And I might also just, in here, I'm going to saturate this as well. Alright, so first things first, we just want the near, fix up the near. So the near distance there, but the scale should be quite a bit smaller, right? Not that. But the far is now a little bit screwed up. So far, I don't know how far this camera is, but let's say it's set to 20. The far scale we set to 0. Okay. So as you can see here, we've got a pretty good control over how thick the lines should be at certain positions. So even at this distance back, we probably want to give it some. I never want the lines to get thinner than this. We'll just try and get these to look right. That's probably about right. So that's how we want it to behave at that distance. Maybe we do even lower that a little bit more. There we go. So what I'm going to do is I'm just going to save my my thing here as the original as well. And I'm just going to undo these. Panels, material. So just put that into there. Duplicate this guy. Just put the original on there. Now, the next thing I'm going to do is I'm going to set this to white background, same as the texture we got in there. So it's black. We're just going to be able to see exactly how this is looking by comparison when we change these things around. So, among other things, we also have lighting disabled on our one, so it's not quite a fair comparison. Maybe I'll just do an unlit texture. There we go. So now we've got the comparison of how this behaves as we zoom in and out. And as you can see here, we've now got that much finer control over it. One of the things we've lost, though, is we are getting quite a bit of aliasing in here, and that's going to be one that we might just let anti-aliasing pick up. FXAA can probably take care of that. But what I don't like is just that the lines don't get quite thin enough here, so I'll set it to 6. We still want them to be quite strong. Maybe go the distance a little bit further too. We're using a 20-meter far distance, which is probably not good enough. Might have botched that one up by using negative numbers, but it doesn't hurt. So we'll set that to 100. I just want to get this looking roughly right. This is probably a little bit too big up close, so we don't really want lines that big. Let's set it to 0.99 perhaps. Oh, I think part of that is also the texture. The texture, if you look at it, is that's the minimum thickness, so we would never be able to go smaller than that. So one of the techniques for getting rid of that is just simply to not paint with a thick brush. Instead, on this, what we'll do is we'll just open up that other one. And on here, I'm just going to shrink that by, I don't know, 4 pixels. No, too much. Contract by 2 pixels. I'm just going to delete everything else that's not in there. Okay. Now we've got a much thinner line inside the thing, and that should let us get a minimum in here that's a bit more representative of what we're looking for. As it's worth noting, when you've got these depth field textures, you can actually just simply alter this fairly easily from within the shader now. So I can actually set that down to, I think that was 6 before. I'll set that down to 0 now. We just need to keep modifying these scale values until we get something that looks kind of what we want. We may even consider doing this as a three-way transformation instead of just doing the start and end values. We might add a midpoint as well, just to give us a bit more control. There's never so much thing as too much control when you're in these kinds of projects. So what I want to avoid is the situation where it goes completely black when you get too far out. But nonetheless, that gives us a very basic starting point for what we want to do. Now, I actually think we do want lighting in this. I know it deviates a little bit from our reference images. If I go sort of tab through these, there is some degree of lighting here. But what we might want to do is consider, instead of using a traditional lighting algorithm, what we might do is we might actually go with a gradient-based coloring system. So if we go to the Unity surface shading examples, there was, and it may have been removed in the years since I've actually done this on here, there was a custom lighting solution that let us do a gradient-based system. So custom, yes, I think the lighting examples, maybe it's here, maybe it's not. Yes, we've got a toon ramp lighting system, so we might just very quickly put this in. So I'm going to add this into our code. We'll just add this as a multiplier on a basic lighting system. What we'll do is we'll actually extend the full PBR lighting path here and do a sort of a hybrid model like the upcoming Borderlands game. And we'll do that probably in our next tutorial. But what I will also try and just sneak in is a in fact, I'm going to drop the need for the ramp entirely, and I'm going to do this as a background gradient as well. So we use this as background 3 and 4. I'll call this unlit. But we will leave the lines the same color. I think that might create a bit of an interesting effect. So just cut and paste all these guys. Now declaring quite a few variables here, so we'll do a cleanup pass on this as well at some point. So we've got our texture 2D here. So I'm just going to change this around. So it's no longer going to be doing this, but instead the diff. So we've just got a diff value there. So we'll just do simply, and I'm just trying to think, so we'll do that as a ramp between. We might need to do some further modifications to this in the final pixel values. So we'll just do it as background 3 and background 4. And where we've got the standard model, I'm just going to go with this original one. So I'm just going to comment out the PBR stuff. We will bring this back in probably next week. 1, 2, 3, 4. Just set it to ramp. So instead of using the standard lighting model, we're now using the ramp lighting model. It'll probably turn black. Did not. I'm going to change some of these things around, just so we've got a clear outline of exactly what it's going to do. Okay, and we've got a shadow that we can include over this. No, we do not. Okay, so next week's project will be getting the shadows looking right. And I realize this is a bit of a build-up towards what our final project is going to look like, but it's key to get these fundamentals in place, because as we start building details, what we want is a really consistent lighting and shading model that is going to bring out what we want. And then what we can do is we can actually start playing with the users' avatars too. very briefly touched on the shader replacement zones before, where we can actually create a zone within a region, and anything that's spawned into that zone will inherit the shaders from the zone. We can actually use that to replace all the users' clothing shaders and things like that, so that they pick up on these same shaders that we're building, and that means that when you sort of arrive in one of these cartoony looking zones, your avatar won't be completely out of place. That said, we are now out of time, so I'm going to take on my office hours now. We will pick this up next week, and then we can go into things like the actual cell shading, where we're going to make cell shading around the box itself, and just fix up a few more of these shader bits before we get in and actually start building the environment. But hopefully this has been interesting, if nothing else, and it does showcase a few of the techniques that we've used before to make interesting non-photorealistic environments. Cool. See you all next week.